Hello everyone, how are you guys doing today? I hope you're all doing amazing. Welcome to another video. Now, before starting today's problem, I wanted to discuss some quick things with you guys. I have been exploring a lot of JavaScript and React lately and been doing some courses on my own. Now, previously, I wanted to do some full stack projects on this channel where we will be building some AI image generated gallery or we'll be building some document query LLM. We'll be making a UI for it, making it a clean interface where you can maintain your documents, create knowledge graphs, and stuff like that. And for that, we will require front end at the end of the day. So if you are guys also interested in some content where we try to learn front end, I came across this series where by greatfrontend.com where they provide 75 most important interview problems. Now, I don't want to particularly treat them as an interview problem. I want them to be more of a test of knowledge for React and JavaScript, and we'll try to understand these concepts before getting into full stack projects. So if you are interested in such videos, just let me know in the comments down below. We can start working on this GFT 75 most important front-end interview problems using JavaScript and React parallelly to our LeetCode problems. But enough on that. Just let me know in the comments what you want to do. Let's get started with today's problem, which is Jump Game 2. Now, this problem is an extension to the problem we did yesterday, which was Jump Game 1. And I highly recommend watching that video before getting into this problem because some of the concepts we have to use in this problem builds up from the problem we discussed previously. And yeah, I think it's comparatively a trickier problem because you have to use all of your learnings from your previous problem and somehow use them and build upon them to come up with a solution. But let's first discuss the problem before getting there. So in this problem, you are again given a zero index array of integer nums of length n, and you are initially positioned at zeroth index. Now each array element represents how much forward from that index can you particularly jump, and you finally wanted to tell in the previous problem whether you can reach the last index or not. Now in this problem, you are already given that all of the test cases are generated such that you can actually reach the final index, but you have to finally tell what are the minimum number of jumps it will take you to reach that last index. So how can you go about solving this? Now let's take an example again. Let's take it to whiteboard and try to understand what we are actually doing here. So our example in this case is 2, 3, 114, which is the same as the previous example, and you want to return 2 in this case, which is the minimum number of jumps. So how can you come across 2? Let's try to do it manually first, and we'll try to build up a solution from there. So you are initially at the 0th index, and you want to tell what are the minimum number of jumps you have to take. So when you are here, you can either you have the maximum potential to reach the second index, so you can either jump on the second index directly or you can jump on the first index. So you have these two options with you. Let's mark them with a different color. Yeah, I don't know if it's the best color or not, but okay. So you can reach these two indexes from your first array. Now from here, uh, again, you have two options. So from 3, you can either jump on this particular element. Let's change the color for now. I don't know that. So when you are at the first index now, you can again have the potential to move 3 forward indexes. So you can either move here or you can move here, or you can finally reach actually in this case you can actually reach the last index directly from the first index, and that will be this jump. So from 3, you have the potential to cover these 3 cases. Now it will be a bit dumb to jump from 3 to here because you are wasting another jump. You are jumping from 2 to 3, and then you waste another jump to reach 1 where you could have actually finally reached 1 directly. So from 3, you actually have the potential to reach these two indexes. Uh, and those are your jumps. So basically, what you are trying to maintain is somehow you want to see that uh, whenever you're trying to traverse through your array, what is the max potential you can reach from each index, and do we actually have to jump to reach that index or not? And when do you actually want to make a jump? You always make a jump when you have reached a particular point that is greater than your max reach potential. So when you were at 2 at the start of the array, you wanted to make a jump to reach any forward because your max reach potential before you even started traversing the array was 0. So you wanted to make a jump here because to reach any forward, you wanted to increase your max reach potential, which was 2 in this case, and you wanted to make a jump to actually reach the points that cover that potential. And when you are at any point in that potential, you will have to make a jump forward from there when you reach an index that is greater than that previous arrays maximum, so your max potential. So whenever you reach a particular point that is greater than your max potential, you will have to make a jump there. So what you want to basically maintain is what is your max potential when you are traversing the array, which we already know from the previous problem. We solved it the similar way where we try to maintain a particular variable which store the max reach potential for us, and at the same time you also want to maintain what are the jumps you have had to make till now. So to reach the particular index you are at right now, what were the number of jumps you have to make, and how will you decide that? Well, you decide that on the basis of your current index and your max potential. So whenever your current index is actually equal to your max potential, when you have reached a place where you can't move any forward to, considering your max potential till now, you want to make a jump here. So I think the problem makes sense. Let's try to dry run our solution for once, and then we'll go and code it up. So let's rewrite this application because I think we have made a shit ton of errors here. Yep, let's clear up. So our array again was 2, 3, 1, and 4, and we said we want to make a jump whenever we have reached a point that is at our max potential. So you always want to keep a point in your array that stores your max reach, which is your max potential of jumps, which we had maintained in the previous solution as well. So that remains the same. Other than that, you want to maintain your minimum jumps till now. What are the minimum number of jumps you have had to take till now? And you will keep adding to this based on your jumps you have to make, that you are forced to make to move forward. So that's how you will increment this, and then you will have another array, another variable which will store your current end. So it will store like what is the final value you can reach based on your previous values, and you will update it only when you have reached the index that is actually at your max reach. So whenever you have reached an index that you can't move any forward to, you want to see what is the max reach from that particular index, and you will want to make a jump again when you have again reached a point that is equal to that current end. So that is equal to your max reach. So you'll initiate all of these values at 0. So your max reach is initially going to be 0, your minimum number of jumps is initially going to be 0, and your current end is initially going to be 0. And you will want to see, like when you are traversing your array, you are starting at the 0th index, and you will want to check that how much jumps can you make from here. So what is your max reach? So your max reach from this index is again, as from our previous problem, I plus nums I. So that would be updated in your max reach, because this value in this case, which is 2, is greater than your max reach till now, and you will update this value to be 2. Now when you go to check whether your current index, which is I, is equal to your current end, you see that yes, your current end, which was actually 0, is equal to your current index. And in that case, you want to update your current end to your max reach. So your current end will be updated to 2, and your minimum number of jumps will also be incremented to 1, because to reach any further from 2, you will have to make a jump. So if you had an array of a single length, you will not have to make this jump because you already are at your final index. So you want to make no jumps. In that case, you would not even start traversing the array. And we'll come to that later, because we want to see where do we want to stop traversing the array, and that will prevent us in the cases of length 1, which is our other extreme. But before that, let's try to understand this part. So whenever you are at 2, you have to make a jump to move forward. So now you have already made one jump, and your current is now updated to 2. So now you are at your first index, and you can see that your max reach is now 5, or 4, sorry. So 1 plus 3 is 4. So your max reach is now updated to 4, because you are at your first index. And from here, you see that your I is currently not equal to your current end. So you could have reached second index from 2 directly. So you don't want to make a jump, because you know from 2 you can reach 1 as well, and you don't have to make another jump for it. So that's why you don't want to update your minimum number of jumps, and you go to your next element. Now in this case, your max reach will be 4, and your this value's reach is 3, which is not greater than your max reach. So you don't update it, and you also don't update your current end. Actually, you do update your current end, because you are at an index where you have reached your maximum potential, you have exhausted everything, and you can't reach any forward from here if you don't make a jump. And that's why you update your current end here, and you say that your current end is now updated to your max reach, which is 4. So you can reach 4 without making any more jumps. And then you also update your jumps to be 2. And then you see when you're traversing the array that you don't want to reach any forward, and you never want to iterate over your last index, because you already know that you will always reach your last index. And if your current end covers your last index, that means you have solved the problem. So you only want to iterate till your len nums minus 1. So you only want to go till your second last index. If you have reached that particular place, you know that you have made all the jumps needed to reach your final index, because you will eventually update your current end if it was equal to your index. So I hope it makes sense. I hope it was not too confusing. I think the color diagram is the best part to understand it. So whenever you are at 2, you can either jump to 3 and 1. So you only want to update your jumps when you have reached 1. So you know you can't move any forward. You don't want to update it in between, because you know that from 3 you can reach 1 without even making a jump. And from 3, you know that you can reach all of these 3 indices, and you will only want to update your index when you want to jump any forward from here. And that's why you never want to cover the last index, because you don't want to make any further jumps from there. And that's why you don't want to check that is this index the last index we can reach or not. Because if you have reached the second last index, and the second last index, let's say, was your current end, you would have updated the jump from there to its max potential. And we know that there will be always a solution. So we know that the jumps will be covered. And without confusing you too much with all of these diagrams and all of this brain thought, let's just start writing code. And I think that should clear a lot of mist out of this problem. So you want to maintain 3 variables, which is your current end, and it will start at 0. You also want to maintain your current reach, or let's say max reach, that will make more sense, that is 0. And you also want to maintain your minimum jumps, which is going to be your final answer. And you want to iterate your array starting at 0, and you want to keep going till your length -1. So you only want to iterate till your second last index. If you have reached your second last index, you know that you have added for the jump from there to reach your final index, and you want to increment by 1 in each case. Now, when you are iterating the array, you first want to check what is your max reach, and to check that, you are just going to check if your I plus nums I is actually greater than your max reach. And if that's the case, you want to update your max reach to be I plus nums I. And after that, you also want to check that if your current index, which is I, is equal to your current end, which is the max index you could have reached till now, you want to update your minimum number of jumps by 1, because you know that to move any forward from here, you will have to make another jump, and you want to move forward from there because you are only iterating till the second last value. And at the same time, you will also want to update your current end to your max reach. So your current end is the max reach of your array till now. And finally, you just want to return your minimum jumps. So that should be your solution. I hope it makes sense. So again, as we discussed during the whiteboard session, we are just maintaining our current reach and trying to check at what point have we reached that current reach, and we have are forced to make another jump. And so that's why I wanted to explain this blue-green kind of thing here, where you don't want to update your minimum jumps each time. You only want to update your minimum jumps when you have reached the index that was unreachable from your previous max reach. And that's why you want to introduce another variable to maintain it for you. And that's why max reach can't help you to achieve both of those things. And yeah, so that's taking care of that intermediate jump increment. So you don't want to increment the jump here, because you know you can reach 1 from 2 directly. You only want to increment this when you have reached the point that will not allow you to move forward before making another jump. So think of jumps as more like a cost, like each rupee that will allow you to move forward. So it will give you the potential to make more jumps, and that potential is calculated in terms of your max reach. And that's why we are updating the max reach, which is getting updated in the current end, and max reach is updating at each point, which is maintaining what is the potential throughout the array that we have seen. And yeah, let's just try running this before speaking any further. And wow, it's taking a lot of time. Cool, it is accepted. And yeah, so that's the solution. I think this particular problem is a bit tricky, and it might not be that well understood in the first go. And also, the solution is not the most straightforward solution. We have to maintain two different conditions here. And doing the previous problem actually helps a lot. If you have done jump gain 1, that allows you to solve this problem. This particular part works as a block for you, which you are already aware of, and you only focus on this particular block where you want to decide when are you actually forced to make a jump in this particular problem? So yeah, again, highly recommended to watch that video before watching this. And that's your solution. Let's submit this and let's see how much people do beat this time. Good. Again, so we beat 100% in runtime, and the runtime 0 millisecond. As always, we have been seeing a lot of this in our Golang exercises. I did used to get a lot of 0 ms when I was doing Python, so that's the positive of Golang, I guess. And in memory, we beat 85.91%, and it's constant memory and linear runtime. I hope that made sense. You're using a single loop, and you're using 3 constant variables that are not getting incremented. So yeah, so your memory is constant and your runtime is linear, and that is your solution right there. I hope the solution made sense. Let me know in the comments about the 75 interview problems for front end. I will love to make this content, and I'm very excited about it. I'm anyway gonna make live streams where we'll be doing some front end full stack projects, and I'm very excited for that as well. So stay tuned, subscribe, and see you next time. Bye bye.